Children, now we discuss what is sign convention for mirrors. And we studied sign convention for mirrors, and almost all the rules are given by New Cartesian sign convention. According to the New Cartesian sign convention, and there are a set of rules that will help us to find or to measure some of the distances in a ray diagram. And this is the first rule. All the distances is to be measured from center. In the case of mirror, all the distances we measured from pole of the mirror. Pole is the center, but here in the case of a lens, optical center is the center, and all the distances should be measured from the optical center. So take the optical center as the origin. You can measure U or you can measure V. You can measure the height of the object or height of the image. But everything should start from, all the measurements should start from the center of the lens or optical center of the lens. That is the first point. And second point, the distances measured to the left of the lens is negative. Distances measured to the left of the lens is negative. Distances measured to the right of the lens is positive. Distances measured above the principal axis is positive. Distances measured down to the principal axis is taken as negative. Okay, so these are the different rules given by New Cartesian sign convention. So these are the different rules. Okay, first rule, all the distances are to be measured from the center of the lens. Okay, second rule, the distances measured to the left of the lens negative, distances measured to the right positive, distances measured above positive, distances measured down to the principal axis is negative. So these are the rules given by New Cartesian sign convention, and these rules are helping us to find the different measuring different distances in a ray diagram. U, V, H1, H2, focal length. So these are the F. So these are the different distances we measure in a ray diagram. So these rules, by knowing these rules, we can easily find the measurement, and we can properly apply the sign for the different terms of the lens. Okay, so that is all about sign convention. Children, this is the lens formula. We studied mirror formula before, and same way we have a formula that connects the terms U, V and F. So this is the relation. The reciprocal of the image distance minus the reciprocal of the object distance, that is equal to the reciprocal of the focal length. Here V stands for image distance, or distance of the image from the center of the lens. This is the object distance. This is the distance of the object from the center of the lens, and this is the distance between the principal focus and the center of the lens O. So these are the different terms, or this particular formula connects all the different terms of a lens U, V and F. So by knowing this, and we can find the unknown value. Suppose these two of the values are given, we can find the third value. Suppose these two are given, we can find. So this is the lens formula which relates the different terms U, V and F, where V stands for image distance, U stands for object distance, and F is the focal length of the spherical lens. So whatever be the type of the lens, and this lens formula is common for both concave and convex lenses. Okay, children? Children, magnification produced by lens similar to that of spherical mirrors. It is defined as the ratio of the height of the image and the height of the object. So it is represented by the letter M, and in the this is the height of the image h dash divided by h, and this can also be given as M is equal to plus V by U. In the case of mirrors, it was negative. An extra negative sign was there with the equation, but here the magnification formula is plus V by U will give you the magnification of a spherical lens. And this is another equation, h dash by h. Here h dash stands for height of the image and h stands for height of the object. Here V stands for image distance and U stands for object distance. By knowing these two equations, we can equate and we can calculate the unknown term very easily with the help of the equations of magnification. So there are two equations. Okay, children? And now we study about the power of the lens. So what is meant by power of a lens? Power. Power is defined as we have already learned that ability of a lens to converge or diverge light rays depending on its focal length. For example, a convex lens has short focal length, bends the light rays through the large angles by focusing them closer to the optical center. Similarly, concave lens is very short focal length, causes high divergence than the one with the longer focal length. The degree of convergence in the case of convex lens, it is a converging lens. What is the degree of the convergence of the convex lens? Or in the case of a concave lens, it is a diverging lens. So what is the degree of divergence in the case of a concave lens? That is denoted by a new term, power. So power is defined as the degree of convergence or degree of divergence. Okay, and it is also written as it is the reciprocal. We can easily calculate the power by using the expression power is the reciprocal of focal length, or P is equal to 1 by F, or F is equal to 1 by P. So one is the reciprocal of the other. So P is equal to 1 by F, or F is equal to 1 by P. And by knowing this, suppose you are given with the focal length, we can find power by using 1 by F. And if you are given with the power and if you are asked to calculate the focal length, that is also possible with the help of the second equation of power. So by using the equations, we can easily find the focal length out of power, or power out of focal length. And it is used, or it is expressed in the unit of diopter. Diopter is the unit of power. Power is defined, or power is written in terms of diopters. 1 diopter is the power of lens whose focal length is equal to 1 meter. P is equal to 1 by, if focal length is equal to 1, power is equal to 1 diopter. So we can define what is diopter. 1 diopter. 1 diopter is the power of the spherical lens whose focal length is equal to 1 meter. Okay, that is in meters. So 1 meter. And power is defined as the 1 diopter is the power of a lens whose focal length is 1 meter. So you may note that the power of a lens is positive and that of a concave. Convex it is positive, and concave it will be negative, because F is positive in the case of a convex lens and negative in the case of a concave lens. So power can be positive or negative, that depends on the sign of the focal length. Okay, convex sign F is positive, so power is also positive. Concave focal length is negative and the power also will be negative, because we are calculating it by taking this equation P is equal to 1 by F. Here we substitute if F is negative, here there will be an extra sign that will consider as the negative power. If there is no extra negative power, we will take power as the positive value. Okay, so with this we completed the portions. Okay children, thank you very much.